Generative AI in education is currently underutilized. In most classrooms, it functions as a basic search interface or a tool for generating high-speed summaries. This limited application reinforces passive habits. Students receive information without having to engage in the heavy lifting of critical analysis. To move past this, we look to Dr. Mohammed El-Batawi's framework. He utilizes Gemini not as a reference tool, but as a strategic teaching assistant. This approach treats the model as a core component of pedagogical engineering. The student moves from a static plane of information into an evolving labyrinth where every decision influences the environment. Pedagogical engineering shifts the focus from content generation to the construction of active environments, where learning and assessment happen simultaneously. This process begins with the foundational logic of instructional design. Next, we examine the mechanics of gamified simulation. Finally, we see the student evolve into an active producer of knowledge. AI is a world-building engine. When deployed correctly, it pressure tests student reasoning and forces the application of theory in real time. Instructional design starts by identifying the target learning outcome before any materials are developed. Gemini executes this through backward design. It traces the logic from the final outcome to establish the parameters of the summative assessment. Once that assessment is defined, the AI calculates the specific interim activities required for the student to reach that level of competency. This structure allows for differentiated instruction at scale, meeting the needs of students with different baseline skills. In an Arabic reading module, the system generates the same core content at 3 distinct complexity levels. A student learning Arabic as a second language receives a text with simplified syntax, while an advanced learner faces complex rhetorical structures. While the inputs differ, all pathways converge to test the exact same foundational outcome. AI-driven backward design ultimately ensures that deep personalization does not come at the expense of the final target standard. Effective teaching requires moving students away from passive reception and pulling them into dynamic, high-energy active engagement. By applying role-playing and simulation constraints, we shift the AI from a search engine to an interactive participant. This enables the creation of a cognitive escape room. These simulations present a series of challenges that require the student to use critical thinking to progress through a narrative. Within this narrative context, the student interacts with a digital manuscript. They must find and correct grammatical errors to resolve a linguistic paradox built into the story. Correctly identifying the subject and predicate immediately triggers the rapid progression to the next stage of the simulation. The AI isn't simply recording a score, it is generating narrative consequences based on the student's mastery of the material. The cognitive escape room makes abstract linguistic rules essential for success within the simulation. A common concern among educators is that gamification might sacrifice measurement for the sake of engagement. The stealth assessment framework addresses this by making the measurement invisible to the learner. By instructing Gemini to act as an assessment expert, we create an invisible layer that tracks performance using a 4-level rubric. The system tracks the cognitive domain, measuring how accurately the student applies grammatical rules during play. It also monitors the psychomotor domain, analyzing the student's response time and their trial and error methodology. Finally, it evaluates the affective domain, measuring perseverance and frustration management as the puzzles increase in difficulty. Reflection checkpoints integrated into the game require students to justify their choices to earn in-game rewards. After the session, the educator uses a data-driven debriefing. The AI analyzes student performance to find specific patterns of misunderstanding. This allows teachers to enter the next lesson with a precise map of where the class needs additional support. Stealth assessment provides a continuous stream of data without the stress associated with traditional testing. At the highest levels of learning, the relationship between the student and the AI shifts. The student becomes a knowledge creator. In this role, students design their own game frameworks and set their own learning objectives. Students use the AI for quality assurance on their own designs. The student directs the AI to create distractors for a puzzle, then plays through the scenario themselves to test the structural integrity of the logic they've built. This closed-loop ecosystem has significant implications for how schools operate. Prompt engineering must be recognized as a core competency for educators, integrated into professional development. Assessment strategies must move away from high-stakes testing in favor of formative stealth assessments. Success in this field depends on building communities of practice, where educators share successful prompts and rubrics across institutions. Integrating AI into the learning process changes the underlying architecture of cognitive development